Okay, so yesterday we were talking about that part of persistence, right? Persistence, caching and persisting and collision repartition. So quickly I will go through that and then we will start from the next one. So here for this collision repartition, as we already discussed, this Coalesce is having a where we can provide any other parameter, any number, and this is used to reduce the number of partitions in a data frame, and it avoids full shuffle of data, and it is optimized for the scenario where data can be reduced without any extensive data movement. And internally it performs an error transformation because of no data shuffle. Most of the time there can be something as well, we can't completely deny, and partitions are consolidated by merging that adjacent one and by suiting the reducing the numbers of partitions. And this is faster comparing to repartition because of this minimized input and output operations. And most probably or most of the time this is used only when we are trying to reduce the number of partitions and not the increasing, like consolidating all the data as a single file or n number of files, whatever we are looking for while writing the data. Okay, like when the number of partitions need to be reduced, then we can go with the college. And for the repartition, that is also same. Either we want to reduce or increase the number of partitions, but as repartition takes care for evenly distribution as well, so we go for this whenever we are looking for processing time. That okay, I am going to process parallel, and parallelly my data should be divided across the nodes with even volume. Then processing will be fine. Nothing will be having more load balance and some is having uh, low. That will not be happen. Everyone will be having almost equal workloads and they will be working fine. So this is that. And then if you go through this comparison wise, then Coalesce reduce the partitions. Even you can use for increasing, but we do not use it. A repartition we use for increase or redistribute. Redistribute in the sense, let's say initially you had 10 partitions. Finally, you thought that, okay, I am going to do some 100 partitions. You increase that. Again, again, you did some transformation. Let's say you did filter. After filtering, you feel that, okay, 30% of data got removed after filtration. Again, you did something, maybe some joins or something. After that, you want to redistribute the data with some different number of partition. Then you can do that. Transformation wise, this is narrow and this is wide one. Performance wise, this is faster because there is no shuffle or minimal data movement. And for the repartition, it is slower because of full shuffle. So whenever it is not required, we can avoid that. Use case wise, this is a small to medium data. Reducing the files, let's say you are having 10 GB of data, finally you want to write that as a Parquet file to the target location, you can plan for okay for 5 GB, you can plan for 2 files as output file. And this repartition is for large data sets and balancing the partitions while processing over the nodes. For the cluster resources, this is efficient because of less network and input-output operations. And repartition is expensive because of high network IO. Here you can see I have mentioned for one lines when you should use Coalesce and when you should use repartition. So this Coalesce is to reduce partitions to write fewer files and avoid unnecessary shuffles. And this repartition increase parallelism and balancing skew data. Skew data we will cover later. Okay, what is skew and how we can overcome from that. Then
Yes.
we
One,
have
sorry,
yes.
just a question. So, what is the real life? Have you ever used in a project Coalesce? Repartition, I know. Or something, suppose if you have big
Always,
data.
always I have used in my all the projects.
Okay, so,
What happens? What
mm,
happens? Let's say we are getting the data. Means I am getting the data in my project from the source. That is, means if I talk about my project particularly, then we are getting zip files from the source. Okay. That zip file is that zip file contains XML files, and that XML files are having its meta files also, and meta files are in JSON. So let's say if that is the device data. So for one of the device, there can be multiple timestamp data. That means maybe device is having some refresh. This is 10:18, 7:18. So by 7:18, maybe 9 a.m. again some updates, and afternoon again one of the updates. That means the device data is same, but because of little bit updates, there are different files gets generated. Okay. So suppose that for one of the device, at the end of the day, I am having some 20 updates. So 20 files. So what we are doing in our project, we are picking the latest file out of 20. How we are getting that? Because of with the timestamp, because all files get generates file name underscore timestamp. So we can get, okay, this was the latest one. Okay. Then we are getting that, we are extracting from the zip, we are converting that, we are validating the XML, we are converting that XML to JSON for the easy processing. And at the end of the day, our files are in, if we count, that is in the billions. Okay. Means I can say like kind of 20, minimum 1-2 billions. Okay. Like that. So that
Small
many
small
files are
files.
there. No, no, not a small files. File size are minimum kind of it, if file size is minimum, then also it will be kind of 1 MB. If not
Okay.
1 MB, then maybe some 700 KB, 500 KB, like that. Otherwise, sometimes file can go up to 50 MB also. One
Okay.
files. So at the end of the day, sometimes we can see that okay, our data is ending with some terabytes. Okay. If let's forget about terabyte, I am assuming that today I get some 50 GB only, and I am delivering the files as a Parquet file to my end team. Now 50 GB file, 50 GB data, I will not deliver as a single file, right? That will
It's
be
mix
having
of
multiple
versions. Yeah.
multiple challenges.
Yes.
Yeah, so in that case, we create 5 GB files. So let's say if my total, we simply check the size of the data, what is the size in the MB, and based according to that, we take the decision, okay, how many numbers should be there, and accordingly we apply Coalesce, and we target for 5 GB file for each one. That is better. That is not a small size also, that is not a bigger size also. That is good for transferring over the network as well. And the end user team who is using that, they can also easily take that, whatever they want to do on top of that file, they are doing with that. So we use on daily basis.
Yeah.
And not in this
Most of the
project,
time just to
not in
write
this project only. I have used in many projects.
So, what I understand, repartition is used. Suppose we are working on something, some skewed data is there. Then fast will repartition it. Then we will do the development, basically write the logic.
Okay,
Coalesce
so
is
for the
something.
same for the same project, let's say I am saying that we are getting millions and billions of records. Okay, we are processing. If I will not do repartition, then by default maybe it can create 1,000 partition also, because it's a Spark internal thing, right?
Yes,
If it
yes.
is creating 1,000 partitions and I am allocating only 10 executors and 5 cores, that means I am having total 50 resources. How 50 resources will be working with that 1,000 partitions? They will be going to queue, right? And
Yes.
if that is going
So
to queue, then that is not helping me.
will be basically
So
as per your clusters, you will just repartition them to 50, something like that. Yeah.
Correct. So I do not want to have any queue, and I want everyone to keep on processing at the same time. And again, small files means that many small files will be getting created. That many times it is going to travel over the network, and then they are going to. If I am not good doing Coalesce also, then that many files will be keep on generating, right? So we handle for the processing time according to the resources. We clarify. Okay, these are the means these many repartitions. If I am doing, then my parallelism will be fine. Then accordingly, based upon the resources, we can decide the repartition number. That's the good practice.
Got it. Got it. Yeah.
Okay, I think you wanted to say something else.
Sorry.
No, you wanted to say something else
No, no, no.
on top
I
of
got
this.
no. So most probably, what I understand is most probably, if see bigger files, and skewness is there according to your cluster numbers. They will repartition it before the development so that there will be no issues. And suppose it's medium small files, then we are going to write it in those case scenarios. Basically, Coalesce will help. Basically, we'll write it in single file or something like that. Yeah, but
Right.
I will use it. But once I do some hands-on, I think I'll understand it. Yeah.
Yeah, sure.
But
And
it's yes.
for that, you can take at least 1 GB of file for the input. If not
Okay.
1 GB, then at least 500 MB. See, a small file means what happens most of the time. Let's say you are trying to practice for optimization. You are trying to see how much time this is taking for the processing and how it is reducing that processing time. If you have differences with micro milliseconds, you will not be able to get it right. We can identify at least it is having some seconds differences, not millisecond also. Is let's assume that you are having 100 records, 100 row, and in another data you are having some 120 row. Do you think that are you going to get some differences?
No, no, I know. Spark means the data should volume should be high, otherwise there is no
Right.
benefit.
Otherwise, for both you are going to get almost similar times. So you will not be able to understand the differences. Okay, how much time this took and how much time this took. So at least you can get the differences. Keep one file 50 MB, keep one file 500 MB. Then see the differences how this is behaving. Okay.
Okay, I'll try. I'll try in my office system. Let's see.
Okay. Fine. Then next we have cache and persisting where we were left yesterday. So as we discussed for this cache and persisting, these are the crucial optimizations that helps improving the performance by storing intermediate results in memory or on disk. And both operations allow data frames or you are working with RDD to be reused across the multiple actions or the stages. And this is going to prevent the need of recomputation of the data or reapplying the transformations you already done with some steps. Here for the caching, this is a shorthand version of persisting with the default storage level of memory and disk. Okay. And when we cache a data set, Spark attempts to store it into the memory. And if there is enough memory that is not fitable to memory, then some partitions may not be cached and will be recomputed when accessed later. Otherwise, this may dump to disk. That is Spark internal thing because this is going to use by default memory and disk persistent level for caching. When we talk about persist, then persist provides more control because whenever we are working with the data, that time only we can decide how I am going to persist the data. If I think that I am working with very small data set, then I can prevent input output operations and I can simply persist with memory only or memory with disk. Or if I think that no, my data is huge and it is going to fail. Let's say I am having some 50 GB file and I am trying to read from the source. When I will be calling any action to get the data from there, and maybe at that time my cluster is not having sufficient memory, I may get exception out of memory. Then because by default it will be trying to caching up the data into the memory and that can be a situation for the failure. In that case we can do the persisting with memory and disk. So Spark can make sure that okay, we as extensively we are looking for memory and disk. So whatever data is fitable to memory, it will be taken care. Whatever is not fitable, that will be going to disk. Of course, this will be time taker. It is going to take some more time if you are comparing with caching because if any data is getting spilled to disk, that means input and output happened additionally. That means it is writing some data to disk. Again, when needed, it is going to read the data from the disk. Again, it will be writing the data to the disk, intermediate data or whatever. So this will be something time taker, but it will be helping you in case of big data, good data amount and limited memory availability. Okay. So the thing is when we use cache and persist, so when we have to avoid recomputation, when we are doing some critical computation and that is taking lots of time, so we can avoid recomputation because Spark computes transformation lazily. When any action we are calling count, collect, write and all, then Spark computes the result. And if the same data set is used in multiple action, then why to repeat the transformation and actions again and again? Why not to cache or do the persisting and later reutilize that? Improve the performance. If you reuse the same data across multiple operations using either caching or persisting, then data can significantly reduce execution time by avoiding repeated calculations. So both are part of optimization. For this caching method stores the data in memory, RAM by default, and is a simplified version of Persist, where storage level by default is memory and disk. And for the data loss handling, if memory is insufficient, whatever you are trying to, some partitions might not be cached and that will be recomputed later. And when you can use it, we use caching when we know the data sets fits into the memory and we want to reuse it across the multiple transformations or actions. And for better use case, we can see if we have data for 1 GB or up to 2 GB, that's good. If you are getting that data is more than that, then don't try for the caching. Better to go with the persist. That will be more better. Okay, because anyways, if you are moving with caching only and the data size is more, than by default this will be moving towards persisting to the disk. Then what is the benefit of that? Then you go directly with persist. For persist, this method allow you to define various storage level as we discussed yesterday. Okay, and this will be giving the flexibility that how data is cached. Either we can store in data in memory or disk or both, either with serialization or without serialization for the efficiency. So here we have some number. I have given 1, 2, 3, 4, 5, 6. First is memory only, where data stores in memory, and if not enough memory, then partitions will be recomputed. If we have given memory only, then memory and disk. This is going to store the data in memory if possible. Otherwise, this will be spilling to the disk whenever it is necessary. That's the property of caching as well. And memory only Sunday. So this is storing the data in serialized format that is going to save memory, but adding CPU overhead. And memory and the disk Sunday, this is also same. This is memory and the disk only, the second one, but this will be serialized. And the fifth one is disk only. This stores data on disk only, and this is really very helpful when you have good amount of data like many GBs or terabytes kind of that, and you are trying to read the file, or in between you have to store the data. Then this is really helpful because that much amount of data either you plan to read in batch in small batches, then it is fine, or if you are doing in bulk at one time, then to avoid all the memory related issue, you can go with this. Then you have off heap. This stores data in off heap memory outside of JVM heap, Java Virtual Machine. Okay, and when to use it? So we use persist when we need more control over the data storage, or if our data set may not fit in the memory. So whenever you have data up to 2 GB, that for the best practice, even you can increase the sizes of that. That's not an issue. You can go for the configuration level also. But by default, that's better. Then you can go for caching. If you think that data is really good amount of data, then you can choose the persistence level, and both are going to help you to avoid recomputation, data recomputation, and making your processing faster. And the entire application is going to be impact if you are doing caching or persisting, because you will be getting some time differences in processing if you are not using and if you are using this. So both will be happening. Is it okay?
Yes, clear.
And then we'll see this practically. Let me create this cluster. So here I have mentioned some examples. First, I will go with this one only. Yesterday we were here and persists. Let me it. Okay. So here I have created one of the Spark session. Okay, repartition and Coalesce, and then I am taking one of the input data. With this input data, I am creating one data frame. I am going to check what is the default number of partition, because when we are not doing anything, then Spark is going to handle the number of partitions internally based upon its own calculation, own logic. Okay. Then whatever you are getting, that is fine, because we do not have control over the data. Sorry, over the Spark. Spark is having its own logic. This is going to use, and accordingly, this is going to provide the number of partitions. So if we want, anyway, this is not required. But here for this practical and for your info, I have mentioned this. So we can check the default number of partitions using get num partitions, and I am how for to check this number of partition, I am converting this data frame to RDD. Okay, df.rdd, and then getting this, and then repartition. Using repartition, here I am giving 4. So when you wanted to increase the number of partitions to distribute the right operations across multiple executors and ensuring better parallelism and faster write. Then repartition is better, because here with get num partition, maybe you are having some random number, either minimum or maximum. It can be, let's say you are having by default 10 partitions, 20 partitions, or maybe one partition only, and that may be better for your cluster capacity, or maybe it is not better. So you can manage with repartition. Okay, and then you have, then we can check the number of partitions once our repartition is done with the same syntax get num partition. Then I am trying to write this 4 partitions data to my output location, because here internally we are not going to check how this is getting distributed. Even you can check that over the cluster. You can go to the Spark UI and you can check for each of the partitions. Okay. So here output path repartition, we have here, this is Databricks, right? So for Databricks, you have temp file, temp location. To that location, you can read and write, you can store the files, but that will be session oriented. Here I am creating one of the folder, and you can take anything. Then I am saying this data frame, which is having the data, then write mode overwrite. You can use append as well. And then I'm writing in the CSV format. And this is my path. To this path, my file should be. We will validate this file as well. Then this is just the print command. And similarly, I'm doing for Coalesce. So this is Coalesce, where I am doing this repartition data, which was repartitioned to 4. Now I am doing to 2. Coalesce 2. Use Coalesce when reducing the number of partitions to consolidate data into fewer files. Okay. And again, we can check the partitions. And here I am writing this data to this temporary file, temporary location with this folder. And again, I am trying to write this. And once here I am trying to write as Parquet file. Here I am writing with CSV, right? So here I am writing with Parquet, where we can do Coalesce 1 and overwrite Parquet, and then my Parquet path. Then this will be writing. Finally, we can see that here I have taken one output path as well. Even you can ignore this one. This is additional. Just I am trying to take one. Already I have taken one Coalesce with the Parquet file. So this will be same. Now, when we want to validate, if you are working your locally, then whatever path you have given to that path, your output file will be available. As here I am doing in Databricks, so I can go to this path and I can verify if my files are existing or not. Means whatever I try to write, that is written or not. I can use this syntax dbutils.fs.ls, and I can provide the path, whatever my path is. And then this will be good to show the files. Here I have commented the temp directory resides on the local disk of the node running the cluster, whatever cluster we have started. And when a cluster is terminated, its nodes are disprovisioned and their local storage is wiped. So if you are writing some files right now, just give me 1 minute. Okay. Then with this path, you can verify the files. And finally, here I am trying to print all the files with the number of Coalesce and Repartition. So let it run. Sorry, it is not yet created. Let me refresh
Pranamika,
this. Yes.
you're working with Databricks. If the session, if
Hmm.
cluster is inactive for I think 60 minutes, so automatically the cluster will be terminated. So again, if I want to execute something, then we need to create another cluster. Yesterday I was facing this issue.
Yes, this is because of community reasons. And you can create many times nowadays. So
This is having some limitations. But this is good, no? You are getting ready-made cluster and you are not worrying about setting up anything. And even you will be not having any unnecessary errors and all, right?
Because I tried 2-3 times Spark on my machine and still I am not able to get it. On Spark only I am facing issue. After setting the environment variable and all these things, I followed 2-3
Mm-hmm.
videos on YouTube as well, but I don't know what is the issue.
Mm-hmm.
So
Do one
I
thing.
go to
Do
the
one
data.
thing. Remove all the. See. Do one thing. Whatever you have set up in your environment variable, clean up that. Okay. Remove all the things. Your whatever setup you have did with which ID you were using.
I was using this header.
No. I can you change that with VS Code or any another?
Note in the header if I check back on the command prompt only, then it was not giving me the logo and all those things. I was facing the error on command prompt as well. After setting the environment variable, when I checked PySpark on command prompt, it was giving me the error.
That can be recollect. So just to clean up all the things whatever you have did and do one more time from the beginning. Okay. So below I have it for caching and persisting. I will comment this. Otherwise, this will be taking lots of time for this as well. Now I am running for caching and persisting, whatever we seen with the code.
skin is stuck for me, or
Okay.
For me also.
Not able to see this.
Yeah,
Okay,
just
give me 1 minute.
Databricks screen and blank, totally white.
Yeah, give me 1. You can let me know now. I will stop sharing and I will reshare. Okay.
Okay.
You are good to see the screen.
No,
Not
still
yet.
white.
Not yet.
Not yet.
No.
My screen is not coming up.
No, Namika. Totally
No, no,
gray.
no.
Okay. I have just give me 1 minute then. Because it should work now. From resharing and then desktop. Not yet, right?
No, should I region also?
And that's what I'm thinking.
Okay, let us region.
now visible.
Yes,
Now
now it's
visible.
visible. Yeah,
Sorry.
Now it's
it's
visible.
visible now.
Okay. You are good to see the Databricks screen?
Yeah.
Yes.
Okay. Just give me 1 minute. Kshitij, you are good to see now?
No. Yeah.
Still
Yes.
no?
Yes, still. No, now it's good.
No, you tell me yes or no.
Yes. It was not there, but now it's there. Good now.
Okay. Okay, fine. Then I have done this already. And just let me check one thing. That is still going. Okay. So here, if you see the output, here default partition is 8. Okay. By default, Spark has taken this number of partition. Then once I did the partition, repartition 4. Then after that, count of partition is 4. Then I am writing this data to temporary location, and with Coalesce, I am taking 2 repartition for the CSV file, and for Parquet file, I am doing 1 because I am doing Coalesce 1. Accordingly, we can verify the files. Once I did repartition, then here you can see this is output file path. Okay, this is single file only, single Coalesce. It was Coalesce 1. And this is output repartition. Repartition, we had 4 repartitions. So here you can see four files has been created. Okay, 1, 2, 16, 17, 18, 19. This is the part files. Accordingly, we have for this temporary Coalesce. For Coalesce, I had given 2 Coalesce 2. So I am getting 2 files, 2 output files. This is the size also. Size also, this is defining what is the size of the file which has been created. And finally, we have this. I had created Parquet file. Parquet file I had created with 1. So here you can see temporary output Coalesce Parquet, and then this is my Parquet file. If you see this Parquet file, then you can see this one dots snappy.parquet. So whenever we create the parquet file, then snappy compression is default with parquet that you will be getting. Even if you want to apply some other, you can apply some other compression, but snappy will be the default one available. So Coalesce we use for reducing the number of files. Here you can see file size is 1161, 1161. So you are getting good size. If you are, so we can plan for some MBs or GBs, whatever we are looking for, and accordingly we can reduce the number of files. So like that we can, and then
Question. Hello, Naviki, one question.
yes,
So the default partition is decided by the number of cores.
yes. A default partition is not always defined by number of cores only. This is a Spark internal mechanism, and of course, whenever we are going for any of the any of the activity, then first what is happening with the Spark? Whenever we are submitting any of the job, then a Spark is going to handle with the all the Spark data and all right.
Yes. So when they decide the how many executors should they use as per the data.
Okay. Yeah. So whenever we talk about whenever we are doing anything, then this is going to create the number of partitions. So in Spark, the default number of partition is determined based upon the input data mostly, whatever we are getting from the source. Okay, and let's say we are reading the data from any of the file, then default number based upon multiple things. One thing is file split. For one of the partition, how many blocks, what is the block size defined internally for that particular environment, particular platform you can say. And then for each block of the Parquet input file, there will be one of the partition. If you're working with HDFS, then of course this will be going with the HDFS size, either 64 MB or 128 MB. And so mostly we can say based upon the block size only, based upon the file splits, how this is getting splitted internally, and not with the number of cores or number of machines. So this is internal setup of the block size. So it's completely dependent upon number of splits.
Okay, got it.
Okay. Oh, just trying to look for something. Okay, then I will uncomment this. And this was for caching and persisting. We already know the theory. So here we have a Spark session, the same data I have taken, and I have created a data frame here. This one, this data frame using create data frame and the column. Then I'm doing I am calling this as a. Then caching the data frame default is memory and disk. This will be capturing the data to the memory if fitable, and trigger an action on the cache of the data frame. Then you can call out any of the action. So if you are going to call this is the syntax for that. And if we want to validate either that data was cached or not, we can simply call this function df.isCached. So it should be returned with either yes or no, means true and false. Then for the persistent level, if you are working with the persisting, then you can do this df.persist, and then within bracket you can define storage level dot memory only or dot memory and disk. and accordingly you can do here disk only and all. Okay, and you can do whatever. Finally, when you know that after this stage this data is no longer required, whatever you did caching or persisting, that you are done with the data, then you always try to unpersist. That is going to optimize your job. If you are not doing unpersist, let's say this option was handling around 2 GB of memory or 4 GB of memory. If you are not doing unpersisting, then unnecessarily that amount of data is going to move around without any reason, without any use, and until unless that JVM your application is available, this will be roaming around. So you can unpersist to save your memory and make your job more faster. You can do unpersist. Okay, and df for all the what wherever you did the persisting means sometimes I did for memory and disk, and I did for disk only, and I did for memory only. And first I had did df dot persist, df dot cache, this one. So for caching you do not have something uncache, but for persisting we have unpersist. So either you do caching or you do persisting. For both you can do unpersist. Okay, and then your data will be cleaned up for the intermediate wherever it has stored intermediate storage level, your temporary memory. Again you can check if you want to be confirm either that is still data is cached or not. Means if you are planning for unpersist, then it should not be available. So you can validate if you like that. Here I have run this already. So let's see.
I think when we store the data in memory only, then we need not to unpersist or uncache, right?
You need
It's
to do.
temporary.
You need to
Memory.
do that. Yes. In memory only. Let's say you have 2 GB of data and you did memory only. Then unless you do unpersist, data will be available, right? And maybe after some
Automatically it will not.
stages you. Hmm. Yeah, go ahead.
Automatically it will not remove.
No,
In memory.
automatically it will not. Data will be existing there. Okay. So here I have just tried for this. This is the data frame which I did cache, and this I did for the persisting. This is the disk only and memory. Sorry, memory only with memory and disk and all. And finally, I am checking if that is cached. So this is true. And after unpersisting, later also I have print if that is cached or not. So this is false. So when I did unpersist, and then if I am checking if that is cache or not, then I am getting false. That means Spark has cleaned up the data. Now data is not available. If you again need the same data, then you have to recompute. Spark will be unable to recompute also, because it has to move to the previous stages and then only it can do the recomputation. So that will be there. Okay. I will create one new notebook that has been lots of, and I will give here narrow transformation 3. That was 2. Okay. So we were there yesterday until caching. So if I go to this document where I have mentioned for all the narrow transformation and wide transformation, you can see the next. we have this casing. This one we were doing, or this is different. This is narrow transformation. Okay. So this is persist and this is caching. And I can copy all this, all the remaining one. This document is uploaded. Okay. If you want, you can go through this. Okay, so here if you see about persisting and caching, this one already you did, so not required. Now coming to count by values. So this is counting the occurrence of each distinct value. If you wanted to do that, and then sample by key exact. Yesterday we were doing sampling also. So sampling, this is same. This is coming with exact count. And take ordered. Take ordered each means it is you can use it when you want to return the first n elements sorted by a specified order. Then you can take this. Min and max. This is the simple one. Wherever you want to return the maximum element or minimum element, you can use this. Similarly, you have subtract and combine. Using subtract, you can subtract element of one RDD from another RDD. I think yesterday we seen this. Okay, that was subtract by key. This is subtract. And one is combine. So combine two RDDs with the specified function. Okay, if you have two RDD or more than one RDD and you want to combine that, then we can. Then map partitions with index. This is one of the transformation which you can use for apply a function to each partition with its index. You are going to work with its indexing and reduce partitions, reducing the data in each partitions to a single value. This is also helpful for some of the use case where you want to reduce. Let's say you are having data distributed with the multiple partitions and you are calling all the data to the single one. Then two local iterator. This is something returning an iterator that can be used to iterate over the RDD elements. Whatever RDD elements are there, you are going to iterate over there. Then you have filter node. Filter out the elements that is satisfying a condition. And min by and max by, that is going to return the element based upon the key, that this is the maximum and this is the minimum. Then you have sample by key. I think this sample by key exact and sample by key, there is no much difference. Okay, sample elements from a key value RDD based on the key. So for the sample we see make more, I think 4 5. If you are good with anyone, that is okay, because this is just for sampling the data, nothing else. Then take sample. This is to sample elements randomly from the RDD. It is not going to scan the entire data. Let's say you are having some millions and billions of records and you want to do the data, then it will not care wherever the data exists on which of the node, either that is in ascending or descending. Randomly, it will be picking some of the data from for your sampling. And then collect as map. This is something we use most of the time. That is to collect the element of RDD as a dictionary. Let's say you want to work as a dictionary where you want to manage the data with key value pair, either by manipulating the data, existing data, or maybe you are going to do with some new additional new additions for the data in the same, or you are having already one of the RDD. You want to treat that as dictionary and then you are going to work on top of that. Then we can go with this collect as map, and once that is collected as map, then you can work around with the data. Then we have random split. For random split, this is going to randomly split the RDD into the specified number of RDDs. Okay. So let me take this. I will copy this and I will comment out this one. Okay. So here, if you see a count by value, so simply we have this RDD and count by values. What this is going to count? What will be output here? Any guess from anyone? We have repeated number.
So I think, yeah,
This is coming to count by value result. 1 1 time, 2 2 time, 3 4 time, and 4 1 time. If I copy this and take this to the input data, then you can see 1 1 time, 2 2 time, 3 4 time, right? And 4 1 time. So it is taking each one edge key, and for each key this is taking some and some edge its value, count by value.
will
Okay,
it work for a text file also if we create RDD through a text file?
of course this will be working out.
Okay, okay.
Okay, so let's say I am saying A, something we can do, right? ABC. This is your text. Then let's say some XYZ, and then do this, run this. ABC1 XY, this kind of occurrence. How many occurrences are there? Simply we say, okay, let me copy this one more time. If you someone asks you to do the word count program, right?
Yes, they ask. Yeah.
So do you think that this can help? What do you
Mm,
think?
yeah, that's what I was thinking. So most probably this is a text file. We have to read the file first. It will not be in a list format. But I've never answered that question, so I do not have that much hands-on. But is that can we use that count by value, or they will say don't
No,
use
this
any?
is doing no ABC 2 times, XYZ
Yeah,
1 time. So you can convert the data to this format and then you can do the count. Simply you can call count by value.
on the RDD. Okay.
That did. So this will be because here if you ABC 2 times in this list means you can convert your data to the list of data and then you call this. Then this is going to take care of it. You do not need to call a flat and flat means mapping and then flat mapping and then do the reducing, right? This is simply this is this got the okay, current. What is the occurrence of this? What is the occurrence of this? So it is getting okay for occurrence of ABC is 2 times. So this is giving you 2.
This is pretty
So
easy.
this,
Suppose we read a file, we'll just make it to a list, then we'll create a RDD on that list and call that function. Yeah, got it.
correct. So this is going to help you. Then
But here, yeah, Anamika,
mhm.
usually word count if we say, so we need to count a particular word from a document or a page or from the list. But here it is counting each and every value occurrence, right?
So two types of word count is there. One word count is whatever words are available, just to get the occurrence. That is what the very simple question, whatever you face in the interview. Okay, that do the word count. Second thing you are saying for a specific word, let's say for ABC only, for XYZ only. In that case, before this count by value, you can do the filter, right? You can filter the data for that exact words or key, or you can I do the iteration. You can run one up the loop, and based upon the loop, you can do for the selective words only. That you have to do anywhere. Either you are doing means if you are doing the count here or you are doing by any of the other method, if that is for the selective keyword, then that selective keyword you have to take up either direct filter or in the iterative loop. Otherwise directly without defining how this will be getting up what you are looking for. You got the point?
Yes.
Means it doesn't know either we're looking for count XYZ on XYZ or ABC or all, right? So let's say you are looking for ABC only. Then what you can do? You can filter this database with ABC, then all this will get filtered out. Then you can do the count, or you loop this, and in the loop you check if data is equal to this or not. If equal to this, then do the count, else ignore this. You can do that. So you have to
There
add
is
one
no
after.
there is no direct method by which we can
No,
provide
no, no.
like count by value in the bracket. We
Eh,
can apply that value and
everything you want ready-made only, right? No, no. So that is not there. For that, you have to write your own function. Okay. That this is the input data and this is what so what you can do, you can define, okay, you can try out, you can define your own function. So let's say count with selected word. Okay. So you do this and then you give two parameters. One is your input data and one is your selected key, and then inside this function you apply your logic, whatever, apply your logic, and finally return final output. That's it. Then you call this function, this will be working out for you. So there is no ready-made function for you. Okay, you have to define your own, then you can. Okay, don't rely so much over Spark or any language. Okay. Okay, then I will take this next one. So this is for sample by key eject. So we have a RDD like A1, B2 and A3. Just to be so this is again like already we did. For A we are looking for 0.5. For B we are looking for 1.0. So if we run this, what happened? There is no output. Or I did not did print. Okay, there is no print. So I should give this. Okay, this is failing. Okay, this was failing, because of that I had commented it out. Okay, so this is just with the percent wise, like we did yesterday. We are looking for sampling, then we can define this. As of now, I will comment. I need to see that by debugging it. So then we have take ordered. This is the one which you can use in your daily basis task. So take order return the first n elements sorted by a specified order, like we have 1, 2, 3, 4, and you are doing RDD dot take order and 2. Then how it is behaving if you are saying take order and 2. So here you can see 1 and 2. If I say let me change the input value here. I will do again 1, 2, 8, 7, 8 something. Then again it is taking 1 and 1. So when it tried to take first 2, then first 2 in sorting it becomes 1, right? So 1 and 1 was the output. And if I am saying let's say I am removing 2 from here and I am keeping, I will remove this one also. Let's say it is okay but not sorted, so there is no duplicate. So it will be taking simply first 2 elements, but in the sorting. That means the entire list will get sorted and then it will be picking up first 2 elements. So here if you see the output is 1 and 2. So this got sorted and first 2 elements was picked up. Then similarly you have min and max. So max returning the maximum element, and I will then comment for minimum as well. And for minimum, we have it will be the minimum element from this RDD. If we print out, then we can get the mean and max. Here you can see max result is 4 and mean result is 1. So if we have to take up the minimum and maximum, then we can go with this. And then we have subtract. Let me comment out. Then I will take subtract and combine at the same time. So subtract, this is one of the RDD 1, 2, 3, 4, and RDD 2 is 2. We just want to subtract RDD1 dot subtract RDD2 and then dot collect. Then this is going to subtract elements of one RDD from another RDD. What will be output? Any guess?
It
3 and
will
4.
be
1,
1
3,
through
4.
4.
1, 3, 4. Okay, we will see that. And for combining, we have RDD1 and we have RDD2. RDD1 is having A and 1, RDD2 is having A and 2, and we are going to do combine. Combine means we have union, right? In SQL also you must have seen union, where you have two sets of data and you want to merge both, then we use union in SQL. Like that, here also we are having union. So you are saying RDD1 dot union and RDD2 and then reduce by key, because that means combine is not having any direct functionality for you. Okay, if you want, you can define your own and then you can call it. And then reduce by key, and we are looking for whatever we want to do. Then finally, let's check the output. So here, this is 1, 3, 4 because 2 was minus between both. Means it was subtracted. And for the combine, it is saying 1 and 3 because this simply did the sum of value. Here it was 1 and here it was 2. And we did that sum with reduce by k, that for each of the key reduce the value. So key is A and value first time 1, second time 2. So 1 plus 2 equal to 3. This is doing x plus y. Okay. Now, so this combine is the mix up with the union and reduce by k. Then you have combine by k. Combine by k is also kind of similar only, where we have combined by key. This is a byte transformation which requires shuffle for key based combinations. And here I have RDD A3 and B4, and initially I am saying that I have two partitions. So how it will be working? Let me uncomment this, then we can, then I will. Sorry. Okay. So if you see how it will be working internally, if you are using combine by key, then first it will be taking the value, create combiner. That means internally this will be initializing the value. And then this is okay. This is wrong. Combine by key. Okay. And then at the later stage, this will be working with combining value with the same partition. This is going to merge the value. Okay. So you can see this is taking this and then it is going to merging that. Then at the third stage, this is going to combine the values across the partition for 1 and then for 2. Like that internally, how it works. This I have tried to give in this one as internal picture. That whenever you are applying, then this is going to take up this, and then finally this is going to print to the output. So like that you can and combine by. Let me print this. So if I take this print, this is saying A4 and B6. A4, A3 and A1. Okay, A is 2 times 1 plus 3, 4 and B 6. So combined by key directly I am applying, but for that I am applying how I am doing that. So creating the combiner, then merging the value. Even directly, if you want directly also you can do without doing all these steps. This is just a little more declarative. Okay, and just it is more readable. You can understand how I am doing that. If you want to do a shortcut, of course you can do, and you can do in a single shot. But better if you are going with the readability and so you can do this. Where it is what it is doing, it is simply combining the key. And if you have gone through all the transformations, then you may see that for the similar thing you are having different transformation. So you can use an alternative as well. If you find that someone is better than this and output is same, then of course you can choose that. Then map partitions with index, where you are having some map, and initially we are giving two partitions, and for that index, this is simply with the name only you can understand this is going to work with index. So we are going to define this idx for the lambda, and then taking this index and then sum of its element. Okay, whatever element we have. Then if we call out it, then 1, 2, and 3. So 0, 1, and 1 and 5. One, two, three. Let me do one partition only. So if I do one partition, then it is saying 0 and 6. How 0 and 6 came? 0 and 6 came because 1, 2, 3, and 3, 6. Okay. Means 0 indexing and 6 count. If I am doing 2, that means data got distributed with the two partitions, and then some will be happening whatever we are doing map partitions with index, then it will be doing separately for each of the partition, not the combined and not with the combined way. So for one of the partition, maybe you have this data, and second partition you have this data. So for single one partition, this is getting count 1, and for second partition this is getting count for 2 and 3. So this was with one of the partition, and this data was with one of the partition. Yesterday we are looking with the GLOM to check the partitions data, so you can use the same. And then we have reduce partitions, where reduce the data in each partition to a single value. So you can have, we have, you can have 2, 3, 4, 5, 10, a number of partitions for the data, right? So for that data, you are trying to reduce the data for each of the partition. So simply you are calling map partitions. Map partition, this is the above one only. Oh, sorry, this is the map partitions with index. But I guess that we had it somewhere map partitions. Okay, this is not in this list. Okay, so you can look into the previous one we had. So let me search this one, my partitions. Yeah, here we have, means day before yesterday we had discussed about this. So we are using the map partitions, and then we are taking that using this sum with this functionality. Again, this is going to work with the partitions only. So this is completely depends upon the partitions. How many partitions you have given for that partition, data has been splitted, and this will be working out for each of the split. Okay, and then finally it will be reducing the output. So this is saying 3 and 7. 3 and 7 means if we say 2, then maybe this data was with the one of the partition, and this data was with one of the partition. So this is coming up with 3, and this is coming with up with 7. So for each of the partition, this is reducing the value, but not, it is not combining, it is not giving you the final output. Okay, do sum for across the partition. So this is not working like that. This is working for the particular partitions only. Then, but again, you are using the same map partitions. Okay, but for the reducing, you are using the sum and all. Then you have two local iterators. Okay, so to local iterator, you are having 1, 2, 3, 4. You can have some sample data, and for that RDD.to local iterator you have available, but your data should be with the list. This is already. If not, you can have this, and you can convert your data type to the list, and then you can call your local iterator. If you are doing the local iterator, then let's see what is the output for this. So this is just iterating 1, 2, 3, 4, no differences. If you are applying some transformations on top of this, then you will be getting it based upon the iteration. Then this is one you use in your examples most of the time. I will uncomment all these three at once. Okay, so this is filter nut. Filters out elements that satisfy a condition. Like you have 1, 2, 3, 4, and you want to give a condition like x is divided by 2 and not equal to 0. Okay. Then this is going to filter that RDD based upon this. And then you have mean by and max. So using filter, you can filter the data with the condition. With mean and max, you can take what is the minimum and what is the maximum. But this is going to above also you see you had mean and max, but that was not working with the key. This is going to work with the key. So you have that means paired RDD. So this is A and A1 and A2 type. Here also you have same data. If you are doing minimum and here you are doing maximum. So if we run this, filter is anyways fine. That was further divisible by 2. What was data? 1, 2, 3, 4. Okay, so 2 will get filtered. And 1 and 3 is remaining. Okay, 1 and 3 is remaining. And mean by result and max by result. So mean by result is taking by key. So for key, this is 1 and this is 5. So there is some differences between mean max and mean by and max by. You can take that mean by max by. This is going to happen with the pair RDD, and mean max that was happening directly. Here we had, right? Yeah, we had max and mean. So this is not happening with the key. This is just simply returning the maximum and minimum element. Then I will uncomment it. Again, sample by key. How many times sampling I have taken? Okay. So this is sampling element from a key value RDD based upon the key. So most of the time you can have simple RDD without key value, and most of the time you have the RDD with key value. In both of the condition you can have different transformation, and that's why you see that with minimal changes you have different transformation because data is different. So here you are having key value RDD. So accordingly your you can have a different transformation. Again, this is the part of wide transformation. So here I am having key value pair RDD, A with 1, again A with 3 and B with 2. We are taking the fraction and then uh, sample by key false fraction dot collect. So with this it is going to take the data sampling. And here you can see sample by key result. Okay, A1 and B2. What we had taken? A 0.5. Let me do 1.0 for both. So if we are doing 1.0, then it took for all two, A3 also and A1 also. And if I did 50%, then it was taking half only. With 0.5, it was taking half. Okay, so 0.5, this is taking this much. So we based upon the given percentage, this is going to work out. And then we have take samples. So let me comment out this one again. And take sample and collect as map and then random split. Take all this together. So taking sample, where you are taking the sample, this is the parameter either true or false, and you are giving to what all samples you are looking for. And then collect as map. Collect as map means whenever you have the data and you want to convert your data as a map, then you can call it. Even you can call it over the data frame also. If you are not having the RDD directly, you can convert that to RDD and then you can take. And here let me just try one thing. RDD data frame df union dot collect. Okay, so this is for collecting directly, we do not have. Okay, so this is collect as map, where you can collect the data as map data. And this is useful when you are planning to work with the dictionary model in Python, either in Python or maybe you are in another, you are using another language, Java or Scala, but you have similar kind of requirement with key value pair, then this is in use. Then random split. This is going to randomly split the RDD into the specified number of RDDs. Like let's say you have 1, 2, 3, 4, 5, 6. Some digits are there, some numbers are there. Then I'm saying train, test, and test one. That means I'm looking for 3 variables. And random split for train, I am looking for 0.8%. For a test, I am looking for 0.2%. And for test one, I am looking for 0.1% out of this entire RDD. So I will be getting the data accordingly. Let me print it. If you see take sample, we are getting 3, 4. Let me copy this. 3 and 4. Let me run one more time. I will be giving some 5, 6, 7, 8. Again 1, 2, 3, 4. So I'm getting 8 and 3. 8 and 3. Do you get something? What is happening? How it is getting the data? This is picking up random data, right? This is not caring for any of the sorting or any of the numbers, whatever. So this is simply selecting the random number from that RDD. Maybe because I have kept some duplicate data also, and that this is not in order. So all the time output is different. If I'm saying sampling 2, it picked up 8 and 3. First time it picked up 3 and 4. That means this is going for the random data.
And if I provide a true instead of false, then
Sorry.
the take sample, if we provide true.
Okay, this one. Let's run this. What did it? 6438. Let me copy this and we'll run one more time. There is no much differences. Do you see something? Again, no sorting or anything, right? So this is 4173. This time it has taken, there is no sorting. Again, numbers are random. So you do
It
not
is
see
working for
much.
both case true and false. So then why it's taking extra parameter?
Okay. You know who is the developer in Apache Spark? No, right? Uh, so the thing is, they are also like us only, who has defined it, who has developed it. We don't know what was the purpose and how they did it. Maybe that needs some enhancement internally, right? Or maybe they have some specific purpose we are not utilizing with that. So that can be. And always they not like that. Whatever they have did, that is okay only, because all the time you may see that some enhancements are coming with each of the version. That means what was wrong, they are keep on enhancing that their model, right? So here, if we look out with the uh, just we have take sample. So whenever we are taking this, whenever we are applying this RDD, most probably we can see that. Okay, let me go to this definition. What it is saying. It is saying that first argument is boolean, then number, then setting that. First, with replacement list, it is asking for the replacement, whether we want to do the replacement with any of the number. And the second one is working with int. So as of now, what you are looking for, either you are giving true or false, so this is not impacting. This is simply going with the integer numbers, right? So first is for with replacement. If you are looking with replacement, yesterday we had seen. If you are going for with replacement or without replacement, this will be working out. So first, for any of the thing, you can simply check the parameters, whatever this is, and then you can take. And if you are not having understanding with replacement, here you see first one, right? With replacement is a list. That means if true, then sampling is done with replacement. Uh, so the same element can appear multiple times in the sample. And if we have taken false, so sampling will be done without replacement, and that means each element with the sample will be unique. So that you can see. If you do it, let's say I am saying, do we have duplicates? 1, 2, 3, 4, 1, 2, 3, 4. Okay, so let me do with true first. Okay, so if we do with true first, then this is true. This will be the differences. This is for with replacement and without replacement. Okay, so let me, this was with the true. Now let's do with false. And now run this. So that is the main difference between true and false. Now use check this one. This is with false. So that means this is not maintaining uniqueness. No unique value. Okay. And this will be maintaining the uniqueness. That's simple. That's the only difference between true and false. Okay. So anytime you can go with the internal implementation for the function, and you can see what is the parameter and it is looking for the parameter, how it is defined. And always if the developer point at the development level, if you think that something is there, then some people I have seen, they raise Jira tickets to the open source community, that this is the thing which can be enhanced, this can be added, or this is wrong, and they get some recognition for that as well. So you can do that also. You can get some contribution in that open source APIs, open source applications, and all. But always they are trying to do at their level. If something missed, we can note it. But here it is okay. This is for the with replacement and without replacement. And then for collect as map. So if we are talking about this collect as map, then if we run this, this is taking the data with your key and value pair, like how we do with the dictionary, right? So your data is getting converted with this format, and then you can work with this. You can see simply a kind of JSON model. Let me add one thing here. One more. D. And I will say hi. This is a character, and let me take it now. Okay, if you see, this is coming with the string. Fine. So this is getting converted with the dictionary data, and now you can work with this easily if you want to do some manipulation. That will be easy for you. Then finally, you have random split. So for this random split, if you see, this is the single data. For this single data, I want to get three variables, three different variables, and for each of the variable, I want some percent from the data, original data. Here I am looking for 0.8, here 0.2, and here 0.1. Then finally printing this. Let's run this. If you see, this is the total data. Okay, this is the train. For train data, 0.8%. Test, it is getting nothing. And for train, test one, this got the data. Now I think this took randomly, and let me run this again. Okay, now this is taking. So this time this has taken this data for this because this is 0.8 so much. For 0.2, this is taking 1, and 0.1 also this is taking 1. So one element because there is no much difference with the data. So let me do this 0.4 or 0.5. 5 means how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me make it one more 10. So this is so randomly this is splitting the RDD with a specified number. This is coming for this, this is with this, and again test one is having no data, 0.1%. Okay, then I need to give it 3. Data is not getting distributed properly. Okay, then it is fine. Let me do it 6. Because this is eating up much data. Okay, now you can see, so randomly this will be trying to split your data among the number of variables you are looking for. So, okay. So always data will be different. So this is randomly splitting the data, and you can split with n number of RDDs. So this is one of the RDD. This is second RDD, and this is third RDD. So you got 3 RDDs from the original RDD, and with some percent. With that percent, this has splitted. So let's say you are having some 1 GB of data, you have created the RDD, and you just want to work with some means some percent of the data. Let's say some 10% or 20%. You are not looking to work out with all because you just want to do some POCs and all. So you can split that, and with that split, you can do your whatever you are looking for the further works. You can do this. So these are the part of narrow transformation, and in between you see some were related to wide transformation as well. But these out of 45, almost 40 were narrow, and 5 or 6 were wide transformation. Again, if you go here, there is another list for wide transformation. So these are wide transformations where you see group by key, reduce by key, joins, left outer joins, right outer joins, full outer joins, and all. So one thing I will say you before starting, I believe that everyone is good with joins, right? See, join is very much a required thing, uh, even for your discussion. And if you forget about interview discussion, then your real time work on daily basis. That is the thing with what you are going to get. So you have to be familiar with the joints. If you are already good, then that's good. If you are not, then please practice it. Okay, because see, only getting the job is not enough. Maybe somehow you can get the job, but finally you have to survive in the job, right? Surviving is the must thing. Let's assume that you get the job somehow and you are not able to do the work. What's next? You will be getting into the PIP, right? Finally, you may get notice, you may get termination, multiple things can be happen. So if we are going to get the job, make sure that if not 100%, then you know 50 to 60%. Then remaining 40% you can learn. If you get the good team members and all, remaining 40%, or I can say 50%. If you know 50% also, 50% you can survive by learning. But if you know only 20%, 80% will be tough for surviving. So these are very basic things. You should know this. And I can give you a real time example. In my recent team, just 4 5 months back, someone for someone got hired for AWS architect. AWS architect, you can understand that was around 15 plus years of experience, and he was AWS certified solution architect. And there were 3 rounds technical. I don't know how he cleared, but he cleared all the rounds with technical team, and all the things was very good. But when he finally onboarded, then we got something else, and that was that uh, his profile was completely different. That means he's coming to data engineering technical team, mostly development team, and his background was DevOps. So DevOps is not bad. It is okay, but he should have tried for DevOps team. But he tried for data engineering, and he got into somehow he cleared the interview also. Now the real challenges started. Real challenges means he had never did git push and all. So this is very basic thing, right? If I talk about 2 years of experience people, I believe that 80% of them are knowing git commands and all if they have development experience, because they are working with the code. So somehow they are of course they are managing the repositories and all. They are managing the code versioning and all. So that should be there. Then what is Python? What is PIP? What is how they can means how we can install the Python? What is IDE? This level of knowledge was lacking. So do you think that if someone is lacking with this much knowledge, that people can survive? What is your guess here? That is not possible, right? So
Yeah,
finally,
but
after
those things they can learn na, if they are proactive. Git push, those things are basically
ah,
5%, 10% of a
but
project.
that is correct. That is correct. But the thing is, now you have to understand the level. A person coming with 15 years of experience, that person is
15
not
years.
knowing. Huh?
Okay.
Architect, no
Yeah.
solution architect.
Oh, then it's not expected
If
that
that
15.
person is 3 5 years of experience, then I will take 1 week or 2 week classes and I will teach, because we understand very well that if someone is coming from the college or means up to 3 years, I treat as fresher. I treat as fresher. That means they are just like a kid, right? They are in the learning phase simply. So we should not expect too much. We should assign the task and we should help to do that, because tomorrow they will be helping someone else. If today I am doing that. So that is the phase. We should help always to our younger generations, and they will be helping tomorrow to someone who is new in the industry. But who is having 10 years, 15 years of experience, we can't expect that. So that's what happened. That person was not knowing anything. Even if someone is asking, okay, we have to do this POC, then what is Python? How to install Python? How to set up the environment variable? How to do this? Then finally we got that if I am writing select a star from table A, join table B, then I am giving table A alias ABC, table B alias XYZ. We can do, right?
Yes, just for reference name. Yeah.
for the reference one. Then that person asked me, even I was only giving the KT. Then he asked me what is ABC and what is XYZ.
And then
Then I
it's
was
most
completely stuck.
probably a tech candidate, something like that. Because this is basics, two
Ah,
basics.
so I can't teach that much, right? That what is the references and all. But I did not said anything. I simply quit and I said that okay, KT is over. But because I do not take anything negativity on my head. So I did not said anything to anyone. I completed my KT part. Then but KT was about to given by the entire team because he was a senior person and he had to know each and everything because he is going to architect the project and all. So almost 8 and 10 people were there. They had to go with their own page and everyone started giving negative feedback, most of them. I included two more people. We did not said anything, either yes or no. But remaining seven gave their negative feedback that this person doesn't know ABC, this person doesn't know this one also, that one also. After 1 month, he got a PIP. After 1 month only. Okay. My manager put him on PIP and then he got released in next second month. So
Yeah.
this can be there.
Actually, I'm not sure why people show that much of experience if they don't have at least they should do some homework at least.
So
Don't.
that's what I'm saying. If you are see, trying is the good, and if in data engineering, data science, this is something. This is a trend in the market right now, and this is something which will never ending because always we have to work with data, right? So data engineering is something which never is going to be end. Some enhancement will be there, new tech stacks will be coming, but this will be always existing. And everyone who is coming, I can say very confidently that 50% people are completely new. That means they are coming after learning. They don't have any prior experience. Confidently, I can say because I can identify the people very easily. But we don't care about that because everyone is need a platform. Everyone needs a time, right? So they are learning and they are switching. But switching is not bad. Only bad is you are not doing your homework. So getting the job. Let's say you are preparing for the interview very well. You somehow you got the job, but that is not enough. I say that you take 1 more month, you take 2 more months, do proper homework and make yourself so you as better that you can survive
Acquainted
well.
with the movement, yeah.
You can survive. So if you know 50% you can learn. Very simply, you will be struggling. Maybe I am working in your team for 8 hours. Maybe this is taking 10 hours for you, 11 hours for you. In the initial days, you have to do some extra work. That will be happening. But after 1 month, 2 months, you will be completely flexible. You will be completely comfortable with your project, and you will be good to do. So keep 50%, 40% for the learning phase and remaining you should learn in advance then you can survive. Otherwise, if you get into the good company and all, you will be having challenges. And for service based there is no challenge. What will happen, they will be releasing you from that project. Again in the bench period you can learn and you can get the another project situation will be different. But in product based there is no concept of changing the project, right? There is no bench policy. You have to work
Yes.
with that project only, and if you are not good then simply they will remove you. So this is more challenging in product based company. You can survive easily in service based but not in product based.
Yeah, because there is no backup. They expect you even in 1 or 2 weeks they will assign a task. Just do it, do it.
In product based there is no bench concept. Simply that from the day one you have to work and from to your day last you are doing the same.
Same work, yeah. Also, I think everyone should also mind that. Suppose I'm working in GCP, I have little bit experience on Azure. Suppose I got an offer in Azure because the interview is different. Sometimes you got the offer. Then suppose if you have 1 month or 2 months of time, just get acquainted with how to create Azure Data
So
Factory
this
pipeline.
this
Just
works. This works because for the cloud experience, anyone can be excellent in one cloud only. Let's say you are working with GCP, I was working with Azure. So I am having expertise in Azure. You are having with GCP, but you know all the concept, right?
yes,
So
same goes for
tomorrow,
other.
if you are switching to AWS, it is not much complex for you to learn.
Yes, yes.
If I am getting something different, it is not complex for me to learn. We can learn. So we should be always good to learn and we should learn. So only that's what I'm thinking. If 50% we know, 50% we can survive. If you don't, if you know 20% only, you can't survive. So before going to the interview, make sure that you know basic things. That's why I was going to that joining points. Tomorrow we will be covering that white transformation. Okay. And for this white transformation, I will say that this is the join concept. If you know already that, then that's good. If anyone who is new and not knowing, then make sure that you are familiar with the joins. If you have any SQL setup and all, you just create two sample tables and you apply all the joins, normal joins, like inner joins, left, right, outer, full outer and all, and try to see the output. What is the input for which of the which of the join, how it is working. If your understanding is better, then the same understanding you will be applying in Spark also, or maybe somewhere else as well. Somewhere else in the sense, let's say tomorrow you are working with some NoSQLs and all. So concept is completely same. There is no differences. That will be helping. So basics should be always clear. This just I said for surviving part because I have seen in the real time multiple times this happens that people are getting somehow they are in, but we can help them only if we have to help a little bit, but 100% we can't help because we have our own assignment also, right? So if we will be working with someone else only for the entire 8 hours, 10 hours, then when I will be doing my own work, I can help for 1 day, 2 day, 1 week. After that, I will be handover. I can't.
Basically, spoon feeding. So nobody likes spoon feeding actually. They expect
Right.
you to pick up their task with little help. You can
Yes.
ask questions, but not like you will is what will the next step? What will
Learning
the
is always good. I like the people who is good to learn. I like them. But if you are not learning, then that's bad.
I'm seeing
Okay.
even for 5 6 year experience also they're asking a simple join questions like 10 100 101 what will the output even now. Yeah,
Right.
everybody they'll that will basically clear that you have understand the joins or not completely.
Right. Simply, see, I also ask the question. If I get the interview for the 10 years of experience people, I simply ask a very basic question for related to joins. What I want to understand, I simply want to understand that you know the basics and basics or not. If you don't know the basics, that means something fishy. It's not good. And if you are clear with the basics, then you can do anything because nowadays we have lots of resources, right? OpenAI, GenAI, ChatGPT, Stack Overflow, Google, everything is there. We have Microsoft. What Microsoft has initiated? I am forgetting the name.
Something Copilot.
Copilot. So multiple resources are there. If you are a good learner, you can get lots of platforms. You can learn that. You can do that. But if you are not clear with the basic itself, none of the resources are going to help you. Copilot or whatever that can't help you because you don't have understanding with the basic level itself, right?
Yeah, basically, you just
So
have to ask the right question in Google.
always copy paste will not help because Chat GPT what does? You think that Chat GPT give always good code? Maybe it will be giving the
You just
expected output, but that is not optimized. You have to optimize because that's a generative AI. Internally, how it works. That generates the data for you, but it is not completely 100%. It is not a human brain. That's a machine. Okay, fine then. Anyways, I am trying to have a session for generative AI as well. Okay. Fine then, let's meet tomorrow and we will start with the white transformation and then remaining part we will move with this Spark SQL and then Kafka setup and then streaming part.
Okay. Thank you.
Okay, fine then. Have a good day. Bye.
Bye bye.